In this question, we have to first picturize the circuit. So we can look at how to picturize the circuit. So we are having three resistors, 3 ohm, 4 ohm, and 6 ohm, which are in parallel. So first let us draw that. 3 ohm, 4 ohm, and 6 ohm. They are in parallel. And a fourth resistor of 4 ohm, which is in series with this network. And after that, it is told that this entire circuit is being supplied by a battery, which is having an internal resistance of 6 ohm. So this is how our circuit will be looking like. So 12 volt source and 6 ohm resistance. This entire part in between these two ends is the two ends, actual two ends of the battery. 6 ohm internal resistance means the battery itself is having a resistance of 6 ohm, but the ends of this battery, we can take it as A and B, will be AB. Okay. So now the first question is to find the total current in the circuit and the terminal voltage across the battery. So as we see here, the second part, we are actually looking at the voltage between A and B. Okay. So now we can try to find the answer to the first question. So in order to do that, we can find the entire resistance of this entire circuit. So first, 3, 4, 6 are in parallel. So the R resistance, equivalent resistance of that would be 1 by R equivalent is equal to 1 by 3 plus 1 by 4 plus 1 by 6. That is equal to 0.33 plus 0.25 plus 0.16. So that will be coming down to 0.74. So this is 1 by R equivalent. That implies R equivalent is equal to reciprocal of this 1 by 0.74. That will be coming approximately into 1.35 ohm. Okay, so the parallel combination of 3, 4 and 6 is 1.35 ohm. That can be connected in series with this 4 ohm. So I am connecting this again 1.35 ohm in series with the 4 ohm, again in series with the 6 ohm, and finally connecting back to the battery. 12 volt source and 6 ohm battery. So the current taken, the first question is to find the total current in the circuit. Total current will be the 12 volt source divided by the total resistance. So that is, current will be going in the clockwise direction. I is equal to 12 divided by 4 plus 6 plus 1.35, that is 11.35. 4 plus 6 plus 1.35. 12 divided by 11.35 will be 1.06 ampere. So the total current taken by the circuit is 1.06 ampere. Now we need to find the terminal voltage across the battery. The battery is of course 12 volt in series with its internal resistance 6 ohm. So we need to find the drop across A and B. This we can assume that B is grounded, and we can know that we can mark the polarity of the battery. And since current is coming in the clockwise direction, the 6 ohm will be having a potential difference of positive in the right side, negative on the left side. So the total voltage of VAB with respect to B would be, as we go from ground to point A, first we have plus to minus, that is drop in potential, that is minus 6 into the current through it, that is 1.06, and there is a rising potential from minus to positive, so that is plus 12. So the total voltage will be 12 minus 6.36, so that is equal to 5.64 volt. So the voltage across the battery will be 5.64 volt. So we have got two answers now. That is, current is equal to total current taken by the circuit is equal to 1.06 ampere, and the voltage across the battery is 5.64 volt. Thank you.